So in the previous video, we went over ionic compounds, and if you remember, ionic compounds was when you take a metal and then you take a nonmetal and you change that nonmetal's, the last part of that nonmetal's word to "ide." Now, if you take a look over here, here's the staircase, and it's usually in bold, a bold line on your periodic table. And anything on the left of this staircase is going to be metals. And anything on the right of the staircase, the right third of the periodic table, is going to be nonmetals. So ionic compounds is a metal and a nonmetal put together. In this video, we're going to talk about covalent compounds. Covalent compounds. And covalent compounds are two atoms put together, two elements put together, but both of the elements are going to be nonmetals. So covalent compounds are a nonmetal plus another nonmetal. And just like the ionic compounds, on that second element, that second nonmetal, you remove the end of the word and you replace it with the suffix "ide." Now there are two big differences between an ionic compound and a covalent compound when writing them out. When we went over the ionic compounds in the previous video, you had to balance their charges out. We had charges, positive charges on the metals and negative charges on the nonmetals, and you had to balance those out so the charges would equal zero, or it would be a neutral compound. Now on covalent compounds, you do not balance the charges out of the elements. So I'm going to write that here. Do not, when it's a nonmetal and a nonmetal together, do not try to balance the charges. Now, why not? Because it won't work. Because these are both nonmetals, and nonmetals in a covalent compound is made up of nonmetals, and nonmetals all have negative charges, so there are no positive charges to balance out anything out. So you don't try to balance the charges in a covalent compound. So we're not worried about the charges in covalent compounds. What we are concerned with when we're writing covalent compounds is the number of the atoms of each element in that formula, which is why we have this little section over here and what these numbers represent, what numerical numbers are represented with prefixes. So if you have a 1 of something, if you have a 1 atom of an element, you're going to put the prefix mono in front of it. If you have 2 of something, you're going to have the prefix di in front of that word. So if you have oxygen, which in a covalent compound or a compound we call that oxide, and you have 2 oxygens in the formula, we're going to say dioxide. So 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So for instance, if we have a formula that says P2O5, how do we read this in words? Now we're going to verify that it is a covalent compound, because P down in the periodic table down here, here's P. P is a nonmetal, and O. O is a nonmetal. So since they're both nonmetals, we know that this is going to be a covalent compound. So the first thing we do after we verify that this is going to be a covalent compound, because they're both nonmetals, we write down the words of the elements that's in here. So this is phosphorus, and this is oxygen. Now the next thing that we do is, since oxygen is the second word in this formula, we're going to cross off the end of it and we're going to replace the suffix "ide" because this is still a compound, so the last nonmetal in the formula ends in IDE, "ide," in a compound uh, in a compound. So both ionic compounds and covalent compounds, the second word is going to end in "ide." Now we're going to look at how many of these elements we have, how many atoms of each element we have. In this 2, we have 2 phosphoruses. So if you look over at the chart, over here, 2 is going to be di, is going to be the prefix meaning 2. So we're going to put that in front of our phosphorus. We're going to put diphosphorus, and then we have 5 oxygens, and if you look over at the chart, 5, the prefix for 5 is penta. So the second word is going to be pentoxide. Or since these two are both vowels, we can get rid of the for penta and we can just put pentoxide. So P2O5 is going to be called diphosphorus pentoxide. So let's try another one. Let's try N3O6. Now down here in the periodic table, here's N for nitrogen, and here's O for oxygen. So we're going to write those down. Nitrogen and oxygen. And the first thing that we're going to do is, well, the first thing we did was check and make sure that both the N and the O, the nitrogen and the oxygen, are both nonmetals, to make sure that this is a covalent compound, which it is. So now what we're going to do is we're going to take the second word in the compound, which in this case is oxygen, and we're going to cut off the end of that word and replace it with ide, I-D-E. So now we have oxide. Then we're going to look at the numbers of each of these atoms, how many atoms are of these elements there are. So the nitrogen has 3 atoms of nitrogen. Now if you look over at the chart, the number chart, 3 means tri is the prefix. So we're going to call this trinitrogen. Trinitrogen. There are 6 oxygen atoms, and if you look over at the chart, 6 is hexa, so we're going to add a hexa in front of this oxide. So the entire N3O6 is going to be called trinitrogen hexoxide. Or you can say hexaoxide, but most people just drop the A so it sounds more smoothly, hexoxide. So trinitrogen hexoxide is N3O6. Now let's try it backwards. Let's take this name sulfur hexafluoride and write the formula for it. And I want to remind you, do not try to balance the charges when you write the formulas for these. That's for ionic when it's a metal and a nonmetal together. But these are all negatively charged anions if you deal with the ions and try to put them together. So you're not going to be able to balance these charges. So covalent compounds do not balance the charges. Now sulfur, if you look at sulfur hexafluoride, we know that the first word is sulfur, right? So we're just going to write down there sulfur. And if there was a prefix in front of sulfur, we'd look up and see what number that prefix stood for. But there's no prefix. It doesn't say trisulfur for 3. It doesn't say hexasulfur. It just says plain old sulfur. So we're going to assume that's an imaginary 1. So there's only one sulfur in this formula, one atom of sulfur. Now this next word, hexafluoride, we're going to bring this down, and we know that "ide" is just the suffix that we used for the compound. So what is this real name of this element? This is fluorine. And then we look at the prefix that comes before fluorine, and that's hexa. So let's look up hexa in the chart over here and see what number that stands for. Hexa stands for number 6. So that means there are 6 fluorine atoms in sulfur hexafluoride. So now we just take these numbers and we put them as subscripts after the element's abbreviation. So the sulfur, the abbreviation on the periodic table for sulfur is S. And since sulfur just has one sulfur, you could put the 1 down here, but you don't really need to because that's implied. So we don't really write the 1 down there. Now the next word is fluorine, and that is an F, and there are 6 of them because of that hexa prefix. We know that there are 6 fluorines. So we're going to bring that 6 down here, and we're going to put 6 as a subscript to F to let everybody know that there are 6 atoms of fluorine. So altogether, this is sulfur hexafluoride is going to be SF6. So let's do one more and write the formula for dinitrogen pentoxide. So first of all, we're going to recognize that the root in this dinitrogen is just plain old nitrogen. So nitrogen is going to be abbreviated as N on the periodic table. And di is the prefix for the number 2. So that means there are 2 nitrogens in this formula. So we're going to bring this 2 around and put it right there at the end of nitrogen. Now we move on to the second word, pentoxide. Now we know oxide stands for oxygen, and oxygen is abbreviated with the letter O. And then pent, or penta, that means 5. So there are 5 oxygens in this formula. So we're going to bring the 5 around and put it as a subscript after the oxygen. So the entire dinitrogen pentoxide would be N2O5. And that's all you have to do.